Welcome to the Chemistry, Biology and Math Revision Hub. Today we're doing the Pearson Edexcel International A-Level, Chemistry Unit 2 for October 2022. Let us begin with the first question. Question 1. Hydrogen reacts with oxygen to produce steam. We can see this is the equation for the reaction, and they've given us the delta H. They've given us some bond enthalpies in this table. So they say, what is the bond enthalpy of the oxygen-hydrogen bond in kilojoules per mole? We know that delta H is equal to the summation of the bonds broken minus summation of the bonds formed. So this is going to be that is equal to 1 hydrogen, which is that, plus a half of oxygen, which is a half of that, minus 2 oxygen hydrogen, since each water molecule has 2 oxygen hydrogen bonds. To make H the subject, the answer is 463.5 kilojoules per mole, and therefore B is the answer. Question 2. Which equation shows the standard enthalpy change of formation of sodium chloride? Standard enthalpy change of formation of sodium chloride is when 1 mole of sodium chloride is formed from its element at standard conditions. So it means if 1 mole of this is going to be a half chlorine and it's going to be 1 sodium, but sodium is going to be solid where chlorine is going to be a gas. So the answer should be A. Moving on. Question 3. Some enthalpy changes of combustion are shown. We can see them here. They say, what is the enthalpy change of formation of ethanol in kilojoules per mole? Now remember, we are looking for enthalpy change of formation, meaning ethanol is made from its element. So this should be carbon plus hydrogen and oxygen making that. But we're given the enthalpy changes of combustion, meaning burning carbon to produce carbon dioxide and hydrogen to produce water. Then the other side, burning ethanol to produce carbon dioxide and water. So in this case, to find that, you have to go like that and then go like that. So this is going to be twice that because 2 moles of water formed. And this is going to be twice because 2 moles of carbon dioxide are formed. And then the other side, 1 mole is burnt, so it's just going to be 1. So the H formation is equal to 2 times negative 286 plus 2 times negative 394 minus negative 1167, reversing everything like that. And I got negative 193 kilojoules per mole. Therefore, D is my answer. Question 4. What is the mass of carbon formed when 1.8 grams of propan-10 undergoes complete combustion according to this equation? Now we know propanol is going to be 1.8 grams, so number of moles is 1.8 divided by the molar mass, which is 60, so the moles are going to be 0.03. The mole ratio is 1 to 2, which is going to be 2 times that, giving us 0.06. So to find the mass is going to be number of moles times molar mass, which is 0.06 times 12, and I got 0.72 grams, so C is the answer. In question 5, which property decreases as group 2 of the periodic table is descended? So reactivity of elements, no, reactivity increases, solubility of hydroxides increases, solubility of sulfates decreases, thermostability increases, so the possible answer is going to be a C. Moving on. Question 6. How many structural isomers with a molecular formula that react with Benedict's or Fehling solution? This is going to be an aldehyde, so we have to find all the possible aldehydes with this structure formula. Remember, an aldehyde has a carbon-oxygen double bond and a hydrogen towards the end, so there is a possibility that it's going to be that. Or a CH3 could come to this carbon here, which is that, or it could be 2 CH3 stretched out on carbon 2, or it could be something in this manner. So I saw there were 4 possible structures, and C is my answer. Question 7. Butane nitrile can be formed by reacting 1-bromopropane with potassium cyanide. Which is the correct mechanism and type of reaction that occurs? Because it's a reaction between KCN, a CN is going to be the nucleophile and the bromo is going to be a nucleophile as well. So this is nucleophilic and substitution, so the answer is going to be a D. In question 8, what produces the color in a flame test? As the metals are heated, the electrons in the atom will transition to high energy level. As they return, a photon is going to be released, which corresponds to a specific color. So the energy change of electrons, that is going to be due to the energy emitted by the electrons and movement of electrons from excited state to ground state. So when they are coming from excited state to ground state, energy is emitted, so the answer is going to be a D. Question 9. Why is the boiling temperature of hydrogen iodide higher than that of hydrogen bromide? Because both are halides that do not have intermolecular hydrogen bonding, it's going to be due to more London forces present in hydrogen iodide. So here, a hydrogen iodide has stronger London forces than hydrogen bromide should be the answer, which is A. Moving on. Question 10. Which nitrate forms oxygen as the only gaseous product on heating? This should be a group 1 nitrate, that is not lithium nitrate. So this is out. These are group 2 nitrates, they are out. So it's only sodium nitrate, which is going to be B. In question 11, which compound has the highest boiling temperature? It's going to be gained by this because it's an alcohol. These are out because they don't have OH group and therefore they cannot form intermolecular hydrogen bonds. But when we compare these two alcohols, we can see this one has more London forces than that, and therefore B is going to be our answer. Moving on. Question 12. Which compound does not form hydrogen bonds between its molecules? When we see water, of course, it's going to have hydrogen bonds. That is going to have hydrogen bonds as well as that. It's only A, which is HCl. In question 13, what is the oxidation number of bromine in this compound? So BrO3 minus. If we like this to be X, this is going to be 3 times -2, which is equal to -1. So the oxidation state of Br is equal to -1 plus 6, which is equal to plus 5. And therefore C is your answer. In question 14, which reaction is not a disproportionation reaction? A disproportionation reaction is where one species is oxidized and reduced at the same time. So we are looking for the reaction where there is no reduction and oxidation of the same species. In A, we can see chlorine from 0, oxidized to plus 5 and reduced to -1. That is a disproportionation reaction. Here we can see oxygen -1, converted to -2, and then 0. This is reduction and that is oxidation. That is also out. Oxygen, converted to -1, reduced, and then +1 oxidized. That is out. And then indeed we can see this is oxidation and this is reduction, but it's not for the same species, so this is not a disproportionation reaction, and therefore it's our answer. Question 15. Which trend is not correct as group 7 is descendant? A. Atomic radius of the element increases. That is true. Boiling temperature of the element increases. This is true because for nonmetals, the more the number of electrons or the more the atomic mass, the greater the boiling point. Electronegativity of the elements decreases. That's true. As you go down the group, electronegativity decreases. Reactivity of the elements increases. This is wrong. Group 7 react by gaining electrons. So down the group, the size of the atom becomes bigger. Therefore, it's harder for electrons to be gained. Moving on. Question 16. The results of an experiment to determine the rate of the reaction between magnesium and hydrochloric acid are shown. So we can see volume of hydrogen on the vertical axis and time on the horizontal. We can see the rate increases until the volume becomes 100. So down here they say, what is the approximate rate of reaction at 40 seconds? So we have to draw a tangent and time is equal to 40 and find the gradient of that tangent. I used the points 102 minus 74 over 60 minus 16, and this is what I got. So this is closer to 0.75, which is required, and therefore this is my answer. And again, remember they said approximate, so any value closer to this, you can see these are so far away, should be an answer. It should be acceptable. Moving on. Question 17. A Maxwell-Boltzmann distribution curve for the particles present in a reaction mixture is shown. So here they say, which statement is correct? Position of X represents the mean energy of the particles. That is wrong. Activation energy EA is the mean energy of the particles that react. That is wrong. The area under the curve to the right of the activation energy EA represents the number of particles with enough energy to react. That is true. To the right, that's true. Adding a catalyst moves the activation energy to the right. No, a catalyst has no effect on activation energy, but it just creates a new pathway with lower activation energy. So here the answer should be a C. In part B, what happens to the distribution curve when the temperature of the gas is decreased? When the temperature of the gas is decreased, meaning at lower temperature, the curve is going to be like that. So here, the curve is going to shift to the left, and it's going to have a higher peak, as you can see here. So the answer should be a D. Moving on. Question 18. Part of a reaction mechanism is shown, which we can see here. So they say which curly arrow in the mechanism is not correct. Let us see. This goes here, and that goes there. And then to this side, we can see this one comes here. This one here is going to be wrong because electrons should be moving from this bond towards that to restore the lone pair. So it's going to be Kali arrow 3. In question 19, a student carries out 2 sets of titrations, one using methyl orange and the other using phenolphthalein as indicators. The conical flask contains sodium hydroxide solution and the burette contains hydrochloric acid. What are the color changes at the end point? With methyl orange, since we have sodium hydroxide, it's going to be yellow to orange. And with phenolphthalein, since we have sodium hydroxide, phenolphthalein indicator in sodium hydroxide is going to be pink, and therefore it will turn colorless at the end. So the answer here should be a B. So this brings us to the end of section A. Let's continue to section B. Question 20. A student carries out 2 experiments and uses the results to determine the enthalpy change when anhydrous copper 2 sulfate forms hydrated copper 2 sulfate, which is that. That is the reaction. In the first experiment, the student determines the enthalpy change when hydrated copper 2 sulfate dissolves in water, which is that. So they say 10.68 grams of hydrated copper 2 sulfate is added to distilled water in a polystyrene cup to give 55 grams of solution. The mixture is stirred and the temperature change determined. The results are: initial temperature is 21 degrees Celsius and the minimum temperature is 18.5. So this is an endothermic reaction because the temperature decreased. They say calculate the enthalpy change for this reaction. Give your answer to an appropriate number of significant figures and include a sign and units. So they say that specific capacity is going to be 3.7 and the molar mass is given to 249.6 grams per mole. At first, I found Q, which is MC delta T. They've given us the mass is going to be 55. So I use 55 times the given specific capacity times the delta T. And the energy guard is 508.75 joules. But I converted this to kilojoules, which is that, by dividing by 1000. Next is to find the number of moles of copper sulfate, which is mass divided by molar mass. The mass is that, and this is the molar mass, and I got that in moles. So delta H is going to be the amount of energy divided by the number of moles. So I got 11.89, which I rounded off to 3 significant figures to give me positive 11.9 kilojoules per mole. Because here they said appropriate number of significant figures, I used 3 significant figures as given here. But here we can see there's a mass given in 4 significant figures. So if you had used 4 significant figures, they would accept that as well. Moving on. In part B, in a second experiment, the student determined the enthalpy change of reaction when anhydrous copper 2 sulfate dissolves in water. So this is the equation, and that is the enthalpy change. They want you to complete the Hess cycle. So here we have this reaction leading to the formation of the hydrated sample. However, since we're given this, I placed it here so that conversion of this to this, meaning from solid to aqueous, is going to be negative 67.4 kilojoules per mole. We also calculated this from previously, so positive 11.9 if I take you back, which is the answer we got here. So that is what we got here. So the next question asks, calculate the enthalpy change when anhydrous copper 2 sulfate forms hydrated copper 2 sulfate. They want you to include a sign as well as units. In this case, to find that, it's going to be negative 67.4 minus 11.9, which is negative 79.3 kilojoules per mole. So this is going to be my answer. So this brings us to the end of question 20. Let us continue to question 21. Question 21. This question is about sulfuric acid. Sulfuric acid is manufactured in a 3-step process. In the first step, we see sulfur reacting with oxygen to form sulfur dioxide, then sulfur dioxide with oxygen to form sulfur trioxide, and then sulfur trioxide with water to form sulfuric acid. They say at room temperature and pressure, sulfur is a solid and oxygen a gas. Explain why sulfur and oxygen exist in different states by referring to the intermolecular forces involved. We know both sulfur as well as oxygen have London forces. However, at room temperature and pressure, sulfur has stronger London forces in comparison to those found in oxygen. So I said, both sulfur and oxygen only have London forces between their molecules. Sulfur molecules have more electrons than oxygen molecules, so room temperature is not enough to overcome the London forces between sulfur molecules, but it can overcome the London forces between oxygen molecules. Down here they say, Step 2 is a reversible reaction, which is that, and this is the delta H. State the effect on the position of equilibrium when the temperature and pressure are increased. They want you to justify your answer. If we increase the temperature, because the forward reaction is exothermic, the yield of sulfur dioxide is going to be decreased. And if we increase the pressure, because we have fewer product molecules, equilibrium is going to shift to the product side. So I said the forward reaction is exothermic, so increasing temperature shifts the position of equilibrium to the left, which is the endothermic side. Then here they say increasing pressure at constant temperature. The product side has fewer gaseous molecules than the reactant side, so increasing pressure will shift the position of equilibrium to the product side. Moving on. Vanadium 5 oxide is used to catalyze the reaction in step 2. Complete the reaction profile to show both the catalyzed and uncatalyzed reactions. Label the activation energy and the enthalpy change. Your diagram does not need to have a scale. So this is the position of the reactants. This is the catalyzed reaction until the product side, and that is the uncatalyzed reaction pathway until the product side. If we see this height here, that is going to be the activation energy of the catalyzed reaction, while that magnitude there is going to be the activation energy of the uncatalyzed reaction. Also, the difference between the energy from the products to the reactants is going to be delta H. Down here they say, explain how the use of a catalyst makes the reaction more sustainable. This question is common. We know that using a catalyst creates a new pathway with lower activation energy, so the reactions can proceed at lower temperature, so less fossil fuels are going to be used. Moving on. Here they say, concentrated sulfuric acid reacts with solid potassium chloride and with solid potassium iodide. Compare and contrast these reactions to show the differences in reducing ability of these two halide ions. In your answer, describe what would be observed and identify the products formed. Now we know when potassium chloride reacts with concentrated sulfuric acid, HCl is formed, which appears as misty fumes, but this is not a redox reaction. However, when potassium iodide reacts with sulfuric acid, we form Hi, which is misty fumes as well. We form H2S, we form sulfur, which is a yellow solid. We form iodine, which is a gray solid. And then we form sulfur dioxide, which is a colorless gas with a choking smell. And because here they said compare and contrast, we have to talk about similarities as well as differences. So here I said, both potassium chloride and potassium iodide react with sulfuric acid in non-redox reactions forming misty fumes. KCl reacts to form misty fumes of HCl gas, while Ki reacts to form misty fumes of Hi. KCl does not react with sulfuric acid in a redox reaction. However, potassium iodide also reacts with sulfuric acid in a redox reaction. Here, various reduced sulfur compounds are formed. So the first example is hydrogen sulfide, which is a colorless gas with a rotten egg smell is formed when potassium iodide reduces sulfur in sulfuric acid from +6 to -2 oxidation state. You can see in hydrogen sulfide, sulfur is -2. Sulfur, which is a yellow solid, is formed when potassium iodide reduces sulfur in sulfuric acid from +6 to 0 oxidation state. In sulfur dioxide, a colorless gas with a choking smell is formed when potassium iodide reduces sulfur in sulfuric acid from +6 to +4 oxidation state. Iodine, a black solid or purple vapor, is also formed when iodide in potassium iodide is oxidized from -1 to 0 oxidation state. Since no redox products are formed with potassium chloride, yet many are formed with potassium iodide, then iodide is a stronger reducing agent. This is a good conclusion. Moving on. In part C, dilute sulfuric acid is used in many laboratories. It is often supplied as concentrated sulfuric acid and then diluted. A technician makes 500 centimeters cubed or 1.5 mole per decimeter cubed sulfuric acid by adding 40.5 centimeters cubed of sulfuric acid to distilled water. Calculate the concentration of the concentrated sulfuric acid in mole per decimeter cubed. So I named this volume 1 as well as volume 2 and concentration 1 and concentration 2. So the volume 1 is 40.5 centimeters cubed, which is that in decimeters cubed. However, we do not know concentration 1, which corresponds to this volume, but we're given the information of the second part. So concentration 2 is that, but volume 2 is 500 centimeters cubed. So this 500 centimeters cubed, again to decimeters cubed, I divided by 1000 and got that. Since the moles transferred from the concentrated solution are the same as those present in the diluted solution, I can try to find out the concentration of that solution. So I equated the number of moles. The number of moles are going to be equal. So concentration 1 times volume 1 is equal to concentration 2 times volume 2. This is true because the number of moles that are present in that specific solution are going to be equal. So concentration 1 is going to equal to concentration 2 times volume 2 divided by volume 1, which is 1.5 times 500 times 10 power negative 3 divided by 40.5 times 10 power negative 3. And I got 18.519 mole per decimeter cubed as the concentration of the first solution. You can write these to three significant figures as 18.5 mole per decimeter cubed. So this brings us to the end of question 21. Let's continue to question 22. Question 22. This question is about the four structural isomers with the formula carbon 4 hydrogen 10 oxygen, which are alcohols. One of the isomers, 2-methylpropan-1-O, is shown. So they say 2-methylpropan-1-O is a primary alcohol. Explain what is meant by the term alcohol and primary. An alcohol is a compound that has OH group as a functional group, and primary means that the OH group is bonded to the carbon that is attached to one alkyl group. In part B, complete the table for the other three structural isomers of carbon 4 hydrogen 10 oxygen, which are alcohols. So we were given this, which is going to be butan 1O. So for butan 2O, it's going to be that, and the tertiary is going to be 2-methylpropan 2O, which is this. We know this is secondary, and this is going to be primary. So moving on. In part C, 2-methylpropan 1O can be oxidized to 2-methylpropanoic acid in a two-step process. So in step 1, we can see the alcohol converted into an aldehyde, and then an aldehyde into a carboxylic acid. They say identify by name or formula the reagents needed to prepare the oxidation mixture. We will need sulfuric acid as well as potassium dichromate. The next they say, write the equation for step 1 using that to represent the oxygen from the oxidizing agent. So this is the alcohol in step 1 plus the oxidizing agent gives us an aldehyde plus water, and the equation is balanced. Next they say, infrared spectroscopy provides information on functional groups. In an experiment, a sample of 2-methylpropan-1O was treated with an oxidizing agent. Show that infrared spectroscopy can be used to show that both alcohol and the aldehyde are present in the resulting mixture. In your answer, refer to any relevant wave number ranges in bonds responsible for the infrared spectrum. Now we know in an aldehyde there is going to be a carbon-oxygen double bond. In an alcohol there is an oxygen-hydrogen bond. So here I said a peak at 1740 to 1720 per centimeter due to the carbon-oxygen bond in aldehydes, and a peak at 3750 to 3200 per centimeter due to the oxygen-hydrogen bond in alcohols. So this brings us to the end of question 22. Let's continue to question 23. Question 23. This question is about bicycles. Bicycle frames have been made from steel and aluminium for many years, but more recently, titanium has been used. Titanium is a metal that is extracted from its ore in pure titanium oxide in a two-step process. In step 1, the titanium oxide reacts with chlorine in the presence of carbon to form titanium 4 chloride, which is that, in carbon monoxide. And in step 2, the titanium 4 chloride reacts with magnesium, as you can see here, to form that. They say write the equation for step 1. State symbols are not required. So they say titanium oxide reacts with chlorine and carbon to form titanium 4 chloride in carbon monoxide. The rest is just balancing. Since we have two oxygens here, we put a 2 here, but the carbons become 2, so you have to put a 2 here, and the chlorines are 4, so you put a 2 here to balance it. Next they say, explain why step 2 is a redox reaction. They want you to refer to relevant oxidation numbers in your answer. In here, titanium is +4, but it's converted into 0, and magnesium is 0, but it's converted into 2+. So we can see titanium is reduced from +4 to 0 oxidation state, and magnesium is oxidized from 0 to +2 oxidation state. Next they say, titanium 4 chloride is a liquid that reacts violently with water, producing white smoke. This reaction has been used to produce never smoke screens two high ships suggest the type of reaction taking place and the compound producing the white smoke. Because it reacts with water, we can say this reaction is hydrolysis, and the compound formed is going to be titanium oxide. Moving on. In part C, many bicycles use an inner tube inside the tire. A common material used for inner tubes is the addition polymer formed from 2-methylpropene. So here we're given the structure of 2-methylpropene. They say draw a section of the polymer showing 2 repeat units. So to form 2 repeat units, I display this. The double bond broke away and then I made 2 connections. So 2 of these connected and then extensions remained here. This is going to be 2 repeat units of that polymer. Down here they say a reaction scheme involving 2-methylpropene is shown. So we can see step 1. This is a halogenoalkane being converted into an alcohol. It could be a reaction potassium hydroxide. Then we can see reaction 2 from alcohol to alkene. That is going to be loss of water, so phosphoric acid is used. And then we can see halogenoalkane converted to alkene. This is going to be reaction with potassium hydroxide in alcoholic conditions. And then reaction 3, converting an alcohol to a halogenoalkane. This could be PCO5 being used. So next they say, for reaction 1, give the name or formula of the suitable agent stating the conditions for the reaction. This is going to be potassium hydroxide and the conditions are going to be aqueous. Then next they say, for reaction 2, give the name or formula of a suitable reagent stating the type of reaction taking place. It's going to be concentrated phosphoric acid and it's an elimination reaction. Next they say, for reaction 3, give the name or formula of a suitable reagent, writing an equation for the reaction taking place. This is going to be PCO5, and the reaction is the alcohol plus PCO5 gives us a halogenoalkane plus POCO3 plus HCl. This is the misty fumes observed. Next they say, for reaction 4, the reagent used is potassium hydroxide. Give the conditions required for this reaction, stating the role of hydroxide ions in this reaction. The conditions should be alcoholic, and the hydroxide ions act as a base because they take away the proton in order to cause the formation of an alkene. Moving on. In part E, many cyclists carry a small cylinder of carbon dioxide to inflate their inner tube. If it is punctured, the carbon dioxide is stored under pressure. So here we see the valve and then carbon dioxide in a cylinder. So they say a gas cylinder contains 16 grams of carbon dioxide. The cylinder has a volume of 20 centimeters cubed. They want you to calculate the pressure in the cylinder at 25 degrees Celsius. Include units in your answer and assume that all the carbon dioxide in the cylinder is a gas. So they've given us PV is equal to nRT and the R value is also given. So using PV is equal to nRT, and remember we're calculating P, so P should equal to nRT over V. So number of moles of carbon dioxide should be the mass divided by the molar mass, which is 44, giving us that. The R is given, so the volume of carbon dioxide is going to be the 20 centimeters cubed divided by 10 power 6 to convert it to meters cubed. And then the temperature we're given is 25 degrees, so we add to 73 to get to 98 Kelvin. So pressure is going to equal to N times R times T divided by V, and I got that in pascals. When I divided by 1000, this was my answer in kilopascals. So this brings us to the end of question 23, as well as to the end of this paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.